Hi there, and welcome to this lesson on Pure Mathematics 1. And in this lesson, we're looking at the sine rule. Now, like the cosine rule, the sine rule works with any triangle, and it has two different uses. But to be able to use the sine rule, you need to know a matching pair. That means you need to know one angle and the side opposite that angle. So that could be angle A and side A, or angle B and side B, or angle C and side C. But you do need to have a matching pair. You also need a third piece of information, but that third piece of information could be any other side or any other angle. Now, if the other piece of information is another side, then you could use the sine rule to work out the angle opposite that side. Or if the other piece of information is another angle, then you can use the sine rule to work out the side opposite that angle. And that's a statement of the sine rule. It's a little bit easier than the cosine rule. A over sine A is exactly the same thing as B over sine B, which is also exactly the same thing as C over sine C. You never need to write down all three things. On any individual question, you'll need to use two of those pairs and decide which pair you need to use. Okay, we'll have a quick look at the proof of the sine rule. And it is a little bit easier than the proof of the cosine rule. All you have to do is draw a perpendicular from one of the angles to its opposite side. So I've drawn a perpendicular from angle A down to the base, BC. And then we use basic trigonometry on both of these triangles. First of all, using the triangle on the right-hand side, the sine of angle B will be the opposite side divided by the hypotenuse, which is h over c. And rearranging that gives us h is equal to c times by sine B. Then we do exactly the same thing with the left triangle. And the sine of angle C is also equal to the opposite side divided by the hypotenuse, which is h divided by b. And rearranging that gives us h is equal to b sine C. Now we found h by two different methods, but both of those things equal h, so they must both equal each other. So b times by sine C must equal c times by sine b. They both equal h. Rearranging that gives us the sine rule. So b over sine b is equal to c over sine c. I chose to work from angle A. If I'd chosen to work from a different angle, then I could show in exactly the same way that a over sine A must also equal c over sine c. And therefore that all three things are the same as each other. Now this version of the sine rule here, where the sides are on the top, this is the easiest form to use if the question asks you to find a missing side. But we can turn all of these fractions upside down if we want to. And that's another way of stating the sine rule. Sine A over A is equal to sine B over B is equal to sine C over C. And when you write the angles on the top, well, that's the form that's easiest to use if the question asks you to find a missing angle. We'll have a look at one example where you have to find a side and one where you have to find an angle. First of all, an example where you have to find a side. So you're given some detail on a triangle and then you're asked to find the length of BC. The first thing you should do is make a very quick sketch of the triangle, just to make it absolutely clear what's going on and what you need to do. So I'll let you have a go at this example yourself, pause the video, and then come back to me again when you're ready. Okay, so the first thing we need to do is a quick sketch. Well, that would be a sketch of the triangle. AB is 5 centimeters. Angle BAC is angle A, and angle BCA is angle C. So angle A is the 30, angle C is the 50, and we've called side BC X. That's the side we've been asked to find. And you'll notice that we do have a matching pair. We know angle C, and we know the side opposite it. That means we're able to use the sine rule. If we didn't have a matching pair, we couldn't use the sine rule. You'd have to use the cosine rule or some other method. So that'll be one pair that we use, and the other pair that we'll use will be this pair here, because we know angle A, and we've been asked to find the side opposite it. So first thing you should do is just write down A over sine A is equal to C over sine C. Now, if you've done things correctly, you'll always be able to substitute in 3 of these values. One of them will be unknown, but the other 3 you should know. Now, the thing we don't know is the very first thing, the length of BC, side A, and that's x, but everything else we know. So you get x over sine 30 is equal to 5 over sine 50. Moving the sine 30 to the other side and multiplying by it gives us x equals 5 times by sine 30 divided by sine 50. And then you just put everything into the calculator, and that gives you the answer that x, or BC, is equal to 3.26 centimeters to 3 significant figures. Okay, example 2 is a little bit more tricky, but not much. On this example, we're asked to find the size of angle ABC, which would be angle B in the triangle. And you'll notice I've written the form of the sine rule where the angles are on the top, because we've been asked to find an angle. So as before, do a sketch first, and then carry on with it. Pause the video, have a go at doing it, and come back to me again when you're ready. Okay, let's have a look. As we said, you should do a quick sketch first of all. It doesn't take long. So the side AB is 4.2, the side BC is 5.5, and it's angle A that we know, which is 38 degrees. And once again, we do have a matching pair. We know the size of angle A, and we know the size of the side opposite it. Now we know the size of this side here, AB, which is opposite angle C, which means we can find angle C. Now we actually want to find angle B. But using the sine rule, we'll need to find angle C first of all, and then use the sum of the angles in a triangle is 180 degrees in order to work out angle B. So the pair that we need to use is this pair. Sine A over A is equal to sine C over C. As always, we should know 3 of those things, and we do. That gives us the sine of 38 divided by 5.5 is equal to the sine of angle C, that's the only thing we don't know, divided by 4.2. This time it's the 4.2 swap sides and we multiply by it, and that'll give us sine C is equal to 4.2 times by the sine of 38 divided by 5.5. Put all of that in the calculator and you get 0.4701. Well, that's the sine of angle C. So we need to do inverse sine to work out C, and that gives us C equals 28.04348. And I won't round it up at the moment. I won't round it up until we get to the final answer. With these questions, it's a little bit dangerous to do your rounding too early. So we found angle C, we actually wanted angle B. That means angle B will equal 180 degrees, take away the other 2 angles. And as I say, I'll leave that unrounded for the moment. That gives you B is equal to 113.9565. And only at the very end will I round that to 114 degrees to 3 significant figures. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 112 and have a go at exercise 6B. Thank you very much for listening, and cheerio.